Hi guys, welcome back from the ad break. So we are still looking at solving some riders that have to do with triangles, right? We looked at the properties of triangles first, all the triangles that we have in mathematics, and then we looked at how we can talk about the theorems and their converses. Now we're going to need to apply all of these in terms of solving some riders. But first, let's just quickly go through the map that we need to go through in order to solve the riders, because now we need to apply it, right? So remember, what did we say? We said firstly you must make sure that you read through the facts part, right? The facts part will be maybe the type of triangle that they told you, right? They told you the type of triangle, or they are telling you about equal angles, or they are telling you about equal sides, right? So those are the facts that you are going to try, and then turn those facts into part of the sketch that we have, right? So if they said in this triangle and in that triangle there are two equal angles, you will then do this and say that and that are equal, right? You are told. And then you go to the implicit facts. So implicit facts will be when they just use terms like this is parallel to that. You know that they are not simply telling you what the properties of parallel lines are, but because you know that they are parallel, then you can think about your corresponding angles, you can think about your co-interior, you can also think about your alternate angles. So that's just an example of what it means to look at an implicit fact. Also, you then continue, after you do all of these things that we've done, the first three things, and I promise you, they're actually the most important things in this particular type of mathematics, which is geometry. And then you go to reading through the asked part. So this is to read the question that is given to you, right? The question that they gave you. What do they want you to do? Right? You will look at things like RTP. What is required to be proven, right? What is required of you? What do they want you to try and show? Then from that, you will then say, okay, if they want me to prove angles are equal, then it means I must start by linking angle 1 with maybe angle C, right? Because at the end, I know that angle C is linked to angle F, which is what I'm trying to talk about. So do you understand? My thinking process will be that. Now I'm saying, all right, so I don't only take all the angles because there are a lot of angles. I'm only going to try and link A, C, and F because they are the ones that I want. So that is my plan of action. Then you go to apply the plan that you have and you always restart again, provided that maybe you think you did not get it right or something that might have thrown you off. Now, the terminology that they use under this concept of riders is what you call the bisect, right? The word to bisect means to cut in half, right? This is to cut in half, right? So if a line is bisected, it means that AB being bisected here, it will make it to be AM, let's call this M, is equals to MB, right? That's what bisected means. Even with an angle, if I say this angle here is bisected, it will be divided into two angles which are going to be equal to each other. So that's what bisect really means. But now let's see how we can apply all of this in terms of the riders themselves. They say BCD is a triangle, all right? So now I know this is a triangle that I'm going to focus on, with BD produced, the very most important thing that you can ever find in mathematics, especially in geometry. This simply just means extended, right? So the line is extended. Now, because of that, the implication is I can talk about the exterior angle of a triangle. Why? Because I know that one side is produced or is extended, right, to the point A. So in simple terms, I can try and talk about angle A being angle D2 being equal to D plus C there, right? Because it will be the interior angle. Now, CE is a bisector of BCD. So BCD, which means that angle and that angle are equal to each other, right? I'm going to show you a proper diagram just in the next slide. Then this also meets AB in E. So that simply just tells us that it is a straight line that is intersecting another line. So we are required to do that. But before we even entertain the question, let's actually apply what they've told us in the diagram properly. We know that C1 is equals to C2. That's a given to us. Now, what else do we know about the angles in these triangles, right? So we need to try and apply other properties that we know. So I know that this will be equals to angle B plus angle C1, right? You see, so this will be an exterior angle of a triangle. And then this angle will actually be angle B plus the whole of C now, right? So it's like 2C1. And that's how you can think about the other properties of angles in this shape. So let's try and prove that D2 plus B, right? So D2, which is this, plus B is equals to 2E2, right? All right, so what do I know about E2? My plan of action is I must try and use E2 because I know that E2 is equals to C1 plus angle B, right? And then I want to make B the subject of the formula, right? But I also know that D2 is equals to 2C1 plus B, right? So you can now see what is happening here, right? What this simply means is if I want to make E2 the subject of the formula, which is at this point, I will then say E1, all right. So I will then say, let me just substitute the B there. I will have B is equals to E2 minus C1, right? And therefore, D2 will be equals to 2C1 plus the angle B there we said is E2 minus C1, right? And then you can see 2 minus C1 will then be what? 2C1 minus C1 will be C1, right? So this will be D2 is equals to C1 plus E2, right? But now I want to make sure that I have twice of this particular E2 here. If I wanted to get twice the E2, I will also use this angle here because this triangle will be an isosceles triangle that I have. So that's what you will therefore need to do. So at the end here, I will need you guys to please use that triangle to try and talk about D2 being that, because I want to just show you one more question and then we can then leave it at that. So when we talk about the terminology respectively, it simply means that is what you are given in the diagram. So here we are told that these are the bisectors of FGH and FHG of triangle FGH, right? Which is respectively. So simply means that this bisects that and this bisects that, right? So that is that one and that is that one. All right, so to apply this, we then know that we are given G1 to be equal to G2. That's because of the bisector. And then as a result, I1 is also equal to those two because of alternate angles, right? And on the other side, I know that H2 and H1 are equal, which automatically will be equal to I3 because of alternate angles. So what do we recognize? That becomes an isosceles triangle and that becomes an isosceles triangle. Now, to solve what they want us to do, the very first thing we know is jk, I mean, is equals to ji plus ik, right? Is this part plus that part. But we know that this is equals to that and this is equals to that. So as a result, I will then say jk is equals to jg plus kh, not kg. Right, so kh. And you can even start by first mentioning that ji is equals to jg and then ik is equals to kh. And that's how you can then solve what the question is asking of us. All right, guys, we've come to the end of our segment for now, which we are going to take a quick ad break, because when you come back, we have some more work that we are going to do. But for now, please stay tuned. I'll be back.